Alrighty, ladies and gents, let's go ahead and get started. Today we're going to be talking about number patterns and sequences, and then we're going to be developing the general term of a sequence. So a lot of action packed in here. First thing I'm going to do is start with these four patterns of dots, and I apologize for the ugliness of the dots, but believe me, I will never judge you on the way you draw. Oh, and I just lost a dot. Alright, that's not good. Let's fill that back in. Alright, so as we can see, we go with 1, 3, 6, and 10. And then but if you look below, you'll see n1, n equals 1, n equals 2, n equals 3, n equals 4. Those n's represent the pattern number. So pattern number 1 has 1 dot. Pattern number 2 has 3 dots. Pattern number 3 has 6 dots. Pattern number 4 has 10 dots. And T sub n, sub being that sub number, represents the number of dots in each pattern. So in the second pattern, you have 3 dots. Pretty fancy if you think about it. Third pattern, 6 dots, so on and so forth. But things you need to know, an ordered list of numbers is called a sequence. Yeah, I know, that's magic, that's pretty cool. And in this case, the number of the dots generate the sequence. So the sequence here is going to be 1, 3, 6, 10. And each number in a sequence is called a term. So anytime you see me with some sentences and you need to just pause the video to write things down to catch up, go ahead and feel free to do that. That's the magic of the interwebs. So how about a little quick practice with taking a look at some sequences? What we're going to do is write down the next 2 terms of the sequence. So maybe I can't figure out how to get from 375 to 75 or from 75 to 15. But I have a pretty good idea of how to get from 15 to 3. I can either subtract 12, which really wouldn't work in terms of getting from 15 to 75, or I could divide by 5. And what I'll see is that dividing by 5 gets me to the next number in the sequence. So now if I need to find the next 2 terms, I'm going to take 3 and divide it by 5. I don't know what 3 divided by 5 is, but I do know that a fraction represents an unfinished division problem. So 3 divided by 5. Then I need to get to the next number. I'm going to take 3/5 and divide it by 5. Now, if we remember the rule for dividing a fraction by a value, dividing by a value is the same as multiplying by its reciprocal. So the reciprocal, the inverse, if you will, of 5 is 1/5. So then I just go ahead and multiply across numerator to denominator. I have 3/25. So then the next term in this sequence is going to be 3/25. And what I'm going to do is go ahead and circle those. These are nice, awesome looking circles. All right, so that's how you can take a look at finding terms of a sequence. But here's where it gets really cool, because now we're going to be talking about the general term of a sequence. If we go back to our triangular numbers, we'll notice in the first one, first number we had 1, first term. Then the second term, we had 1 plus 2. Then we had 1 plus 2 plus 3. And then the next term we had 1 plus 2 plus 3 plus 4. And then you can assume that as we move on from one to the next, that we would just add that next layer. But what we want to do is think about a general term of a sequence. And when we're talking about the general term of a sequence, we're thinking about the equation that best represents how to find these values. So what I'm going to do is try and find a pattern here that'll help me to come up with an equation. So here's what I'm going to do. I'm going to take each triangle, and since instead of dealing with a triangle, what I'm going to do is try and make it into a rectangle by doubling it up. So I'm going to take the values that I have, I'm going to flip that rectangle, and then what we'll see, hopefully, depending on my drawing, or maybe it's better if you don't depend on the ugliness of my drawings, but what we're hopefully seeing is that all of a sudden I've created some rectangles. Honestly, pretend that they're a rectangle. It's better for everyone that way. So if we look at the green dot, in this first value I have n, so my green dot is n. Then when I combine the green and the red dot, I end up with n plus 1. So the total area of this rectangle would be n times n plus 1. Is that true over here? Let's see, I have two dots, top to bottom, three dots left to right. So again, I have n plus 1. And you'll see that that holds true for every pattern that I've created, n and n plus 1. If I have 1, 2, 3, 4 here as my n, I have 1, 2, 3, 4, 5 here as my n plus 1. But Mr. Chavez, you say, that gets me a rectangle. I don't want a rectangle. I want a triangle. Well, what happens if we cut that rectangle in half? Ha-ha! You have a triangle. So going back to the general term, I know if I take n and I multiply it by n plus 1, that's going to get me the whole rectangle. But I don't want the whole rectangle. I only want half of the rectangle because I have twice as many dots as I did before, and I only want half. So the general term, meaning for whatever number in my term, I'm going to take that number that I started with. So for example, 4, t to the 4 times 4 plus 1, which is 5, gets me 20. You see the 20 dots here. And then I divide it by 2 to get me 10, which is the 1 plus 2 plus 3 plus 4. Magic. Straight up magic. So you might be thinking, that's a little complicated, that's a little tough. So let's go ahead and slow it down. First thing we're going to do is let's start with a sequence 4, 10, 16, 22. Let's see if I could find some sort of commonality here. So if I have 4, that's the first term in my sequence. Then I look at the second term in my sequence. How do I get from the first term to the second term? Well, I started with 4 over here. Then to get 10, looking at it in terms of my first number, I have 4 plus 6. Then I look at the third term, 16. It looks like now I have 4 plus 6 plus 6. Because again, I'm going back here and looking at the pattern that I noticed. It looks like each time I'm adding 6 to the original. But in this case, now I see that I have two 6's together, so I can simplify that as 4 plus, let's erase that, that's a pretty ugly plus there. 4 plus 2 times 6. And then to 22, we can see that it's going to be 4 plus 6 plus 6 plus 6. But instead, I can say, we'll just skip over here, that I'm going to start with 4, and then I'm going to add on 3 times 6. So the tricky part may be, how do I make this into a formula? Well, again, let's start with what we know. So our general term, we know I start with the number 4. It's always going to start with the number 4. That's the first term. That's the commonality and everything here. But then the rest of it, here's where I start to look for patterns. So I'm taking a look over here, 4 plus 6. I added 1 6 here, 2 6s here, as we see over here, 3 6s, then I would add 4 6s, 5 6s. But again, I'm looking for a pattern. 1 6, 1 to 2, 2 to 3, 3 to 4. So it's always one less, or one fewer, if you will, than the numbers I had before. So to this equation, I'm going to add, I take whatever number in the term, and I subtract 1 from it in order to get the number of 6s that I would then multiply. So what I'm going to do now is I'm going to go ahead and simplify. I'm going to simplify this using your friend and mine, the distributive property. So let me rewrite this as 4 plus, instead of times 6, we're going to put the 6 on the outside of the parentheses because we know that means I'm multiplying everything inside the parentheses. So that's going to get me 4 plus 6n minus 6. I'm going to combine my like terms. I see I have a negative 6 here and a positive 4. So I can rewrite and get my final answer as 6n minus 2. Pretty sweet, isn't it? So the thing here is that it does take a lot of practice, but the more that you practice, the better you will get at finding patterns. Here's one more to try if you dare. We're going to go ahead and talk about this pattern at the start of class, and like I said, we're going to keep practicing until this becomes a lot easier. That's it for now. Have a good day.